Hello, Ochem, and this is lesson 5, and we're moving into mechanisms. So what we're going to do first is we're going to talk about nucleophiles. All right, and following this video, we'll talk about electrophiles, and then we'll start marching through the different mechanisms, all of which you guys have had direct experience with now in the laboratory. So to start with, we're going to define a nucleophile. All right, and a nucleophile, and you should know this from previous classes in chemistry, all of your nucleophiles are what we call Lewis bases. So basically, not to be redundant, all of the nucleophiles are bases. And you know from previous experience that bases can be strong and they can be weak and so on, and there's an intermediate range. But a Lewis base, what is a Lewis base? This is, now in terms of organic chemistry, we're going to need to talk about molecules. So I'm going to be defining this way. So a Lewis base is going to be a molecule where at least one atom has a free pair of unshared electrons. All right, and I'm going to abbreviate nucleophile as Nu. And I'll just put a pair of electrons on it to be clear about that. So a nucleophile can have a charge or not. Have a negative charge or not. Okay, and an example, okay, so before I get into the examples, so it's a molecule where at least one atom has a free pair of unshared electrons. All right, the pair of electrons is available to form a covalent bond. To form a covalent bond. That's an important thing to put in here. I don't want to leave it out, and I think I'm going to go ahead and underline it. So a pair of electrons is available to form a covalent bond. Now, examples. The easiest examples to compare this issue surrounding whether or not the nucleophile has a charge on it or not is to compare water to its conjugate base, which is OH minus. In the case of water, which happens to be a weak nucleophile, if we draw the Lewis formula, you can see that it has actually two unshared pairs of electrons that are available to form a covalent bond. And in terms of the molecule itself, because of the electronegativity difference between oxygen and hydrogen, the oxygen carries a partial negative charge and the hydrogen carries a partial positive charge. Now, if we look at hydroxide by comparison, which is a relatively strong base, it has the following Lewis formula or structural diagram, and the oxygen itself actually has a formal charge of -1 on it. So here we have the comparison of two molecules, both of which are nucleophiles. Both of them function as nucleophiles. However, the water is weak and the hydroxide is very strong. It's a strong nucleophile. And depending on the conditions of the reactions where these two nucleophiles are utilized in separate reactions, their behavior can be actually quite different. Hydroxide can act more like a base, and preferentially strike protons versus other electrophilic centers. All right, and remember from the previous months of our course that an electrophile is a molecule that has a positive charge on it, or a net partial positive charge. So like in the example of the nucleophile, the charge does not have to be formal. Like this is a formal charge. And by differentiation, if we look over here, the oxygen has partial charges, and the hydrogens. These are partial charges. They're partial charges, they're not formal charges. And the partial charges result because of electronegativity differences. Formal charges result because literally the oxygen is carrying an extra electron after the abstraction of one of the two hydrogens, right? The hydroxide came from water. And what differentiates the water and the hydroxide is the fact that the hydroxide has had one of the two hydrogens removed without extracting the extra electron. Okay, so with that, I'm going to conclude this video as lesson 5, and rather than move on here, and so in lesson 6, we'll look at a list of different nucleophiles, and we'll talk about how they're different.